All right, good morning, everybody. Hope everybody's doing well today. So, got a bunch of stuff to go over, including ODP 402, 403, and Git. So, any questions up front before we start? All right, let's talk about ODP 402. So 402, remember, let's hop on here. So the goal was to write a bash script that reads one line of input, prints out twice that value. Okay, so it doesn't prompt you for anything. It just reads a line, doubles the number, prints it out. Okay. So some of the main things I saw in people working on this, first of all, about 10 or 12 people wrote this in C instead of bash, which is a totally different thing, right? Doing this in C, you have to use, scanf or fgets and scanf, and write a program, compile it, and all that kind of stuff. And if you did it in C because you thought you were supposed to do it in C instead of a bash script, that's okay. Just, in the future when it says write a bash script, write a bash script. If you did it in C because you didn't know how to do it in bash, you missed the whole point of the assignment. Okay? The whole goal of these one-day programs is to give you a chance to know if there's something that you're missing in your understanding, and then give you, a sort of bite-sized project to work on to help you enhance your understanding. So the goal here was to get some practice with making a shell script, with doing input, and with doing arithmetic, okay, from bash. Your first programming assignment, which I'll post probably Friday, will be a bash script, okay, and so you're going to have to know how to do all of these things. If you submitted a C program and you got 30 out of 30 from the assessment, you get to keep your 30 out of 30. Okay, I don't go in and dock people points that they've already been given by the assessment system. But make sure that if it says bash, you do bash. If it says C, you do C, because that's specific to what we're trying to get out of the assignment. All right, so how do we do this in bash? Well, you have to use the read instruction. So if I say read x and I type in something, I should be able to say echo $x and see what the person typed in. And another mistake I saw people making was, instead of saying read I, they were saying read $I. You don't get a syntax error. But if you turn around and you try to echo $I, you see that something went wrong with your read. Okay, so this is my next comment. You should be making sure on your own that your code works correctly before you assess it. Okay, assess is not a debugging tool. And assess is not perfect. It may tell you that your code is correct when in fact it's not. Right? And our goal here is to get some practice writing code that works to do some particular task. So if you're writing a bash script, test it out yourself. And in a lot of cases, people are not doing that. They're writing their script, they're running it through assess. They don't get 10 out of 10, they change it, they run it through assess. You can find out a whole lot more by running it yourself. So, let me make my sample ODP 402. Okay, and this is not going to work. Because I got that $I. But if I try to run this, I get a permission denied right there. I can be putting this in the assessment system. I cannot be getting 10 out of 10. I can be making changes to this for 2 or 3 hours, and never realize that the problem is I don't have the permission bit set to execute this. If you try to run this yourself before you assess, you know that right away. I need to set the execute bit, right? You're going to save yourself a lot of time and you're going to learn more. So go ahead and turn on the permission bit. And now try executing it. And type in your number. And it prints out a 0. Okay, there's no reason to try assessing it at this point. I can see it's not printing out 46, but it is printing out a 0. Well, that tells me a lot more than just running it through assess and getting 0 out of 10. Hey, I wrote this program, it should read in a 23, it printed out a 0, what the heck is going on? Well, let's go back in and let's look at this. If I is 23, it should be printing out 46. So let's see what it's actually reading. Let's put in some debug statements. Let's go ahead and run it. I'll put in a 23. It didn't print out anything, I think. Well, let's do that trick that we heard about the other day. Let's put delimiters around this. Inside quotation marks. And sure enough, the value of I is nothing. So go back into your ODP. Something is wrong here. I'm reading a variable into I, but that variable is not getting set. What's going on? There's links to code from lectures in here, right? Click through on that, and here's all the script examples we had. The args were from yesterday. That was playing with the command line arguments. Here's one called command. Look at that. There's a sample read command, right? Read command, and then we're using the value of $command. Well, that works. Why isn't my code working? Okay, at some point, maybe you take a walk and you come back and you look at this. At some point, you realize I've got a $sign in there. There's not supposed to be a $sign. Okay, do that. Run your ODP. Put in 23. Hey, there's my 46. Fix up your code. Take out your debug statement. Okay, now it looks like it's working. Let's try a negative number, because negatives are sometimes weird. Yep, that works. Let's try a 0. That works. Okay, now go ahead and assess it. And you're almost guaranteed to get 30 out of 30 in this case. At this point, your code works. You run it through assess. If you don't get 100%, there's probably one of two things going on. Either there's a problem with how you're using the assess tool, like maybe you're assessing the wrong program, or you misunderstood the assignment prompt. So go back and read the assignment, make sure that this is doing exactly what the assignment asked for. Right? But chances are, if you've done that and this is working, you're going to get 100% when you assess. Okay? So think about the development cycle in that way. And this is important, right? To be an effective programmer, you need to be able to come up with algorithms to solve a problem. You need to be able to implement those algorithms in code. You need to be able to test your code. And then if it's not working, you need to debug your code. Okay? This is part of the testing phase. If you don't have a way to test your code, how do you know that it works? You run it once and it doesn't segfault, okay, you're going to pass it on to the next person in the design line. No, you really, really want to exercise it. So run it as many different ways as you can, try as many edge cases as you can, thoroughly convince yourself that it works. If it doesn't, then you go into the debug phase, and then you go back to writing the code and testing it. Once it's fully tested and you're convinced it works, then you hand it off to, a QA person. That's what assess is, basically. It's saying thumbs up or thumbs down. All right, does that make sense?
It does. I do have one question.
Mm-hmm.
So, I also tried turning an ODP 403 yesterday.
Mm-hmm.
After several times of getting a 0 out of 10, I realized it was still grading ODP 402.
Right.
Would that 0 out of 10 overwrite the 10 out of 10 I originally got on ODP?
It will, yeah. So go back and redo 402.
Now it's saying it's only grading 403.
Yeah, so when that happens and you realize you've done the wrong one, go back and redo the one to get your 10 out of 10.
It won't let me do that now. Now it's grading.
No, I'm saying for the future when that happens.
Oh, okay.
when you submit the wrong one, go back and do the correct one.
Okay, gotcha.
Shoot me an email and let me know that happened, and I'll pull up your old score.
Cool, awesome, thank you.
Okay, yeah. All right. So again, when you assess this, you'll get a line at the bottom saying you're about to assess your code for. That's where you want to make sure that it's actually the one that you're trying to assess. If it's not, exit out, and it will not do anything. It'll give you a warning that you haven't graded. That's what you want. All right. Other questions on 402? All right, so let's look at 403. So 403 is again a bash script, and in this case, instead of reading an input from the user while the script is running, you specify a value on the command line. So you should be able to say ODP 403 space 12, and it should print out 2 times 12. So here's my version of ODP 403. I won't show you the source code for it. But ODP 403, and I put a number on here, and it prints out 2 times that number. Okay, that's what your goal is. And if you run that and submit it for grading, you should get 10 out of 10 on all 3 tests. So assess sometimes does 1 test, sometimes does 10 tests, right? Different tests. Each test is usually worth 10 points. So you get, in this case, 30 out of 30. The final ODP is graded, you know, with a percentage from 0 to 100%, so it's normalized. But the individual one-day program might have multiple tests that it runs to test different edge cases and such. So, so how do you do this? Well, instead of reading an input and putting it in a variable, we're just going to use $1. So this can really be a one-line ODP, just echo $paren, $1 times 2, right? And that should work. All right, so clear what you're supposed to do for 403? All right. And do it in bash, don't do it in C. All right, so new topic. Let's talk about source code control. So there's all kinds of history about the development of coding as an industry, and as a large-scale practice. And there's lots of studies that have been done in the past, and all kinds of statistics that show basically that you know, the cost of writing a piece of software is one thing. The cost of maintaining a set of software is huge. It's far greater than the cost of development. And this led, you know, in the 70s and 80s and 90s to all kinds of schools of thought about how code should be written, how it should be documented, what languages you should use. New languages were developed. The government developed a standardized language called Ada that was so huge that nobody used it, and so on and so forth. One of the realities of programming is that large projects get complex really quickly, and the complexity starts to explode if you're not careful. And when you're writing code by yourself, when you're working on a one-person project, this can be a little daunting, right? You might have, you know, 20 different pieces of your project in 20 different files, all trying to follow, you know, some conventions while some of them do their own thing, and they all need to work together as part of a larger system, and that can be complex. The complexity gets a lot worse when you're doing team development. When you're working with, say, 100 other computer scientists, and you're all trying to develop some large system. And so you're working on these pieces, and somebody else is working on those pieces, and eventually those pieces need to come together. And I might need part of your code to develop my code and to test it. And somebody else might need access to my code so they can test their system. And if I'm changing my code, the stuff that they're developing might start working differently because I made a change in my code last night. And now they don't know if their code is broken or my code is broken. And it gets to be really complex. So people use source code management systems. And these are ways to sort of track and control changes made to code, different versions of code, being able to go back to older versions of code, and so on and so forth. And there's been a lot of different versions of source code control systems. So CVS, RCS, Subversion, a whole bunch of different things from the past. And so when Linux was being developed, right, this was a team of a lot of people, and they were basically writing all of Unix, right, from scratch so that it could be open source. And there's a lot of code in Linux, right? Mostly written in C, some in assembly language for low-level drivers and stuff, but mostly written in C. But just a lot of code, and as you've seen in Linux, everything is interrelated to everything else. When I pipe two commands in the command line, when I say, something like who pipe into word count -L, right? The way that this pipe symbol is working is related to how the function pipe is written in the C runtime library. So imagine you've got, thousands of programmers working on millions of lines of code. You need a way to manage all of that code. And so the team was using a free source code management system, which all of a sudden the owner of that system decided it was time to make this a commercial product, and they were going to charge for it. And they told the Linux team, you have to pay us a certain amount of money to keep using this software. That did not go over well. And so one response to this was that Linus created his own source code management system. And it was intended to do the things that they needed done to resolve some of the issues they were having with existing systems, and to be free and freely available, so open source. So the system that they came up with, and the system we're going to be using, is called Git. And Git is widely available. It's extremely efficient. It was used for developing Linux, okay? So most of our projects won't be on that scale. So it's extremely efficient. It's plenty powerful for everything we're going to do in this course. It's free. It's open source. It should be available on whatever Linux system you're using. It's available on our Linux server. And it's pretty painless to use once you get it set up and you know how to use it. So our goal today is to look at Git, look at how we get it set up, look at the basic commands, see some use cases for it, and then start moving towards talking about GitLab, which is where we can take our Git repositories and push them off in the cloud and have them saved for us. And this lets us move between machines. It lets us have off-site storage for disaster recovery, and it's also the mechanism you're going to use to submit your programming assignments in this course and future courses with me. So we're going to want to get well versed in Git. So the how-to quick start guide on Canvas has a section on Git and GitLab. And I pointed you to this yesterday and suggested you look at it and go ahead and set up a GitLab account. So I'm not going to read through this for you, but let me hit the highlights. First of all, why do we want to use Git? It's really easy on Linux to lose your work. Okay, it's really easy to think you're in an old directory and you want to get rid of all your files, so you just say rm-rf*. And guess what? You were accidentally in your home directory and you just wiped out all of your files. And they're gone. There's no recycle bin. Poof, they're not there anymore. Okay. I don't do backups on the Linux server. The person who runs the server doesn't do backups on the Linux server. If your files disappear, you're stuck unless you have your own backups. Git is a way that you can make backups, okay, especially if you're using GitLab. There's also disaster recovery, right? Hard drives fail, servers fail. I don't know what kind of redundancy. The Linux server we use, it's a service I pay for. I don't know what kind of disaster recovery they have, if anything. So if something goes wrong and that machine crashes, all your work can disappear from the Linux server. You need to be prepared for that, and you need to take measures to make sure you have backups of your work. Okay, GitLab is a great way to do that. Another reason for using Git is to be able to make changes to your code, but roll back to previous versions. So classic example, you're working on an assignment. It's working 99% of the way, but there's one little detail that's still not quite right. And you decide you're going to stay up and fix that. And you work until 5 in the morning, and your brain's getting tired, and you keep making changes, and it keeps getting worse and worse, and now your code won't even compile, right? You say GCC, and you get 50 error messages, and this is just a disaster, right? You don't know what's happened. You would love to go back to that previous version of your code. And if you've saved it somewhere, great. If not, you're stuck. You have to undo all these changes that you made at 3 a.m. Okay? If you're using Git and you're being conscious of making entries to your repository along the way, you can always go back to older versions. And you can go back to newer versions. Everything is saved, right? Every change that you push into your repository is saved and available to go back to. And there's a log that shows you when changes were made and by whom and why. And all that stuff is preserved. Okay, you can also do what's called branching. So you can start working on a project and you can say, let me see if I can add an extra feature. You can start a new development branch. And everything you do on this new branch is completely independent of the original branch. And at any point you can switch back to the original and your development branch is still intact. And then you can go back to your development branch, continue making changes, and if at some point you get to the point where you're like, yes, this is great, I want this to be my project, you can take all those changes, merge them into your main branch. And if you don't want to do that, right, you can just leave them on the side. And if you merge them in and you decide the next day, I didn't want to do that, you can go back to an earlier version of your main branch. Okay? It's a wayback machine. Everything is saved if you use the system correctly. Okay? And that's really, really useful. And that has definitely saved me a few times where I've accidentally, wiped something out. Right? You want to remove all your C file, all your text files. So you say rm*.txt, but instead of a dot, I accidentally hit a space. If I execute this, it's going to remove every file in my directory. So it's really easy in Linux to get yourself in trouble. So you want to have ways to get out of trouble. An alternative is, set up RM so it asks for confirmation every time it deletes something. I don't recommend that, right? Try to get out of the habit of having to have conversations with your computer every time you want something done. Okay, that's a mindset that will hurt your productivity, I think. This is my experience, at least, right? If every time I try to do something, I have to read a response from the computer and then respond to it with some confirmation, it's going to kill my productivity. Let yourself be productive, but put measures in place in case you mess up. Right? So Git is one of those measures. The other thing about Git is it's a really nice way to sort of build a portfolio of your work. So when you're applying for a job or an internship or applying to graduate school or a research position or something like that, it's very common on your resume to have a link to your GitLab or GitHub repository where people can go and look at projects that you've done. And so it's a nice way to sort of document what you've been doing. Someone asked, couldn't you also have a trash folder? You can set up a trash folder, and you can set up things like RM to move things into the trash. That's not a bad thing to do. It's an option. It's not the default behavior of RM, but you could do that. And yeah, sometimes a trash folder saved me also. All right, so let's play with Git. So there's things that you need to do once when you decide you're going to start using Git, and there's things you need to do once per project, and then there's things you need to do every time that you make changes. Okay, so there's sort of three levels of interacting with Git. There's the one-time setup, which is pretty painless. There's the one-time setup per project, which is also pretty painless, and then there's the stuff you do every time that you make changes and want to push those in. And guess what? That's also pretty painless too. So let's start from scratch. So I will log into my test account on the Linux server, and I have no Git set up here. Okay, if I say Git status, there's nothing going on here. Okay. So I'm just deciding right now I'm going to start using Git. You have to do these three commands here. Okay, these are going to tell the system who you are, what your email is, and what editor you want to use. And once you do this once, it will be remembered forever. Okay, so I don't have to set it up every time I log in. Now you can do this on the Linux server at school. Okay, linuxengrcs.com. I also recommend doing it on your Linux system at home. Okay, and that will let you share code pretty easily between the server at school and your home system. Okay, it's also nice just to experiment with. All right, so let's do our configuration. So I'm going to start from the middle. Git config -- global user.name, and I'm going to give it my name. I'll just do Nick Macias. All right. Git config -- global user.email. All right, and so there's my actual email address. And then if you like using Nano as an editor, that's your default, so you're set, but I recommend using VI. Okay, so git config -- global, and let's do core.editor. And I'll do VI. Alright, that's a one-time setup, and what that's done is it's created a hidden file in my home directory called .gitconfig. And if I look at that file, it's got this information that I just saved. Okay? All of these hidden files that Git creates, I'm going to say don't mess with those. If I want to change my email address, use the git config global user.email command. Don't come in here and edit these files. Usually when a file is hidden like this, it means it's being used internally by a utility. You don't want to mess with it directly. If you mess up your Git configuration, you can trash your repositories. And everything that I've said about being able to go back 6 months and see an old version of your code, none of that's true anymore. Okay? So don't mess with these files directly. Alright, so that's the one-time setup for using Git at all. I don't have to do this again for this account on this machine. Okay, so let's suppose I want to start a new project. Every project should go into its own directory. That's a cardinal rule. Every project gets its own directory. I would say every ODP, put it in its own directory. Keep things clean. Get in the habit of organizing your work. Okay? So let's go ahead and start a new project. I just muted someone, and maybe you were asking a question, but it sounded like background noise. If you were asking me a question, go ahead and unmute yourself and ask it again. So let's make a new project for homework 3. So homework 3 will post in a few days. So I'm going to make directory with mkdir, and I'm going to change into that directory with cd. So my directory is now homework 3 under my home directory. And there's nothing in here. what I should probably have done was something like, make a directory for CSE224, go into that directory, and make a directory, I don't know, maybe I'll call it Homeworks, and go in there, and now make my directory for Homework 003. Okay, that was a little more work, but I'm building a hierarchy. I have my login directory, which is everything, right? I might have 224, 222, 223, CSE 215. So I'm going to separate those out. And in my 224 directory, I might have directories for ODPs, for homeworks, for my own tools, for experimenting, and so on. So I made a homeworks directory, and now I'm in homework 003. Okay, just an idea. All right, so one time per project, you say git init. That initializes the whole git process for you, and you only have to do that once per project. Okay, once per directory. And if I say git status, I can see I've got a git repository here. It says there's nothing to commit. All right, so here's what goes on with git. Here's my current directory. I have a bunch of files in here. Over here is my git repo, my repository. That's where all my stuff is going to get saved. In between those two, there's something called the staging area. And I don't add files directly to my repository. It's a two-step process. First, I put my files in the staging area, and then I say, take everything in the staging area, add that to my repository. Okay, so we do these in two steps. The first step is put your files, whatever files you want to go into your repository, put them on the staging area. This is the git add command. And then, once you've got everything staged, push everything from there into your repository. That's the git commit command. All right, and we're going to do this every time we make changes. We're going to say git add, git commit. And the more often you do that, the more fine-grained a picture you have of your history. Now, if I don't do this until, the last day of a week-long project, I've lost most of the benefit of Git. I have no previous copies of my code, and if, the night before I deleted all my files, they're lost. So you want to do this pretty frequently, but you don't want to go a little overboard with it. You don't want to make one change to one line of your program and then commit everything back into your repo. Okay? You want to do this basically when you're at a point where it's like, okay, I would like to save my current version of my code. Okay? Git is efficient, space is cheap, so you really can't get into too much trouble, doing too many adds and commits. But it can become, more complex when you try to go back to older versions. So let's play around with this. So let's make a main program. Alright, so there's my main program, and let's make an include file, and let's make a readme file, and readmes are usually called readme uppercase.md. MD is for markdown. It's like a markup language, but it's simpler. It lets you do things like put boldface and italics and things like that. A readme is basically, it's a text file that everybody who looks at a repository or a project or a tarball or anything else, if they see a readme, they assume it's got useful information that the person looking at these files should look at. And it says, whatever they need to know about it. This is a test collection of meaningless files just to demonstrate Git operations. And then I'll throw my initials in and the date. right? So I got some files in my directory right here. Okay, at any point you can say git status and get a quick view from git's eye what's going on. Git is telling you you've got 3 files, readme, main, and main, which are untracked, meaning they're not on the stage and they haven't been committed. Okay, and it tells you use git add file to include these files in what will be committed. Okay, right now there's nothing on the stage to be committed, but there are untracked files present. Use git add. So I mean, git status is really telling you what's going on, but it's also giving you hints about how you can fix the situation. Okay, so I want to put these files into the staging area, git add. Normally we want to be kind of nuanced, so we want to say git add main.c. So let me... So we want to say git add main.c. And if I do a git status, you can see main.c is a new file that's ready to be committed, and main.h, readme.md are untracked. Okay, more often than not, we end up just saying git add star. You can do that. Right, now all 3 files are sitting on the stage ready to be committed. But you can get a little sloppy that way. For example, if I had, a really big movie file sitting in here, and I say git add star, well, I've just added a .mp4 file to my staging area. It's probably not something I really intended to commit. And, it's going to take more time, it's going to take space, maybe I didn't want that. So generally, we commit source code, we commit text files, we commit make files. We don't usually commit object files, executable files, things like that. There's nothing wrong with doing that, but usually we're committing source code and things related to source code. But you can use Git however you like. Alright, so these 3 files are on the staging area. They're not in my repository yet. Okay, they're sitting right here. If I want to push them into my repository, it's one command, git commit. So git commit. And this will ask me to put in a message explaining what the purpose of this commit is. Okay, so it throws me into an editor. This is VI because I set that core editor to be VI. If you didn't set that up, this will be nano. So this is a file. It's got information telling me why I'm in this file and what I should be typing in. All of these things with number signs in the beginning, they're like comments. They're not going to go into my commit message. But I can type anything I want here. Okay, very common commit message is stuff, right? Because you're really busy, you don't feel like typing a commit message. That will work, but if you go back 6 months from now and want to figure out what the purpose of this commit was, a message like stuff is not going to tell you. A message like dot is not going to tell you. A message like fixes is not going to tell you. So you'd like to be sort of as specific as you can in your commit message. And hold on, I got landscapers outside. Alright, that's a little quieter. So you want to put a message in here saying, basically what you're doing. So I'm going to say, initial version of main program and include file. I would probably put in something more descriptive than that, and this can be multiple lines. And you can find, whole web pages dedicated to how you should write good commit messages. And when you take a class, at a university, they'll tell you what you should put in your commit messages. And when you work on a job, they'll tell you what your commit messages should contain, and so on and so forth. But this is for you, okay? In this class, you're using Git for yourself. And so your commit messages should be something meaningful to you. For example, I'm going to try to, well, let's just go through this. Let's go ahead and do this commit. Okay, so these files are in my repository, and if I say git status, there's nothing to commit. Everything has been pushed into the repository. Okay, so let's say I'm going to make a change. Let's say I'm going to change main.c to add a loop. So I'm going to add the numbers from 1 to 10. Alright, so I've made that change. I want to push this into my repository. Two things I do: git add, name of the file, git commit. And so here I'm going to say added running sum to calculate 10th triangle number. I'm done. Okay, git add, git commit. That's all you got to do. So git status, nothing to do right now. If I say git log, I can look back and I can see, hey, at 11:42, I made the following change. I added a running sum to calculate the 10th triangle number. At 11:39, that was my initial version of the main program in the include file. So I can see the whole history of all of my changes, and there's this short numeric code I can use to access those old versions of my files. So I can say, let's check out this version, and I can just use the first few characters of this, and I can roll back to a previous version, and then I can roll forward to this version. Alright, and it's all saved under there. So if I look in here, I just see 3 files. Okay, but if I do an ls-a, there's a new directory on here called .git. It's a hidden file, and it's the root of a whole directory containing all of this stuff. Okay, so inside this whole directory tree is this whole history of my changes, different versions of my code, why I changed things, and so on and so forth. Definitely don't go in here and mess with this stuff. You make an edit to one of these files and you might corrupt your whole repository. Okay, but it's out of the way. You don't see it when you normally do an ls, but it's there. If I bundle this directory up using the tar command, my git repository gets bundled with it. I get to save that whole history. Alright, so that's the basic git setup. Do your one-time setup per machine and log in. Do your one-time setup per project, and then every time you make a change, git add, git commit. And it'll track those changes for you. And if you get in the habit of it, it's not a big deal. And you can even make an alias, for git add, git commit, or you can put it in, some command that you use when you're done working on your project. You can say finish, and it'll do your git add and git commit and so on. Okay, and it's just a habit. It's something that took me a long time to get into, but once I got into it, I just live and die by Git now. I mean, everything I do, I don't worry about it. I have backups running on my system anyway, but my stuff is always under source code control, and it's also backed up in the cloud on GitLab, which means I can get to it from any machine. If I have a disaster, if everything in my apartment disappears, I can still get to my code. All right, so let's talk about the cloud piece of this. Let's talk about GitLab. And GitLab is a server that's somewhere and is available for you to take your Git repositories and push them over to that server. And you sign up for an account at GitLab. It's free. You give them an email address, you confirm it, and that's it. You've got pick a username, and now you've got a GitLab account. And now I can associate my local repository with a repository over at GitLab. You do that with another one-time command called git remote add origin. And now, after I do git add and git commit, I can do one more command, which is git push. And everything that I've done here in my repository gets pushed over to the cloud. And it's there. It's saved. It's available. So someone asked what happens when you edit a file when it's in the staging area. If you edit it, once you're done editing it, just go ahead and add it again, and it'll put the new version over there. If you don't do that and you say git commit, I think it will. That's a good question. Will it commit the old version and the new one, or will it refuse? I don't know. All right, so it's telling me I have to push, I have to add readme.md, and that it's been modified. Will it let me commit? I think it's going to commit the old version. Yeah. So I think when you push it on the staging area, it saves that area of it. All right. So we're going to use GitLab. And tomorrow we'll dig into the details of this, but let me give you a quick heads up. GitLab, go ahead, get yourself an account. It's free storage. They have private repositories for free. And it's one of a number of services that let you store GitLab repositories on their servers. Now GitHub, I think, was around before GitLab. But GitHub had the disadvantage originally that you could not have a private repository unless you paid money. So if you had a subscription to GitHub, you could have private repos. Otherwise, all your repos were public. And that doesn't work well for a class. So I started having people use GitLab instead. GitHub eventually got bought by Microsoft. Lots of people bailed from GitHub when that happened. Switched over to GitLab. GitHub is still around. It's still widely used. They might have gone to where you can have private repositories for free. I'm not sure. But we're still using GitLab. If you already have a GitHub account, sorry to make you have another account, but we're going to use GitLab for here. So set an account up on that, and we will go through all the details of this, setting up a public-private key, adding your project to GitLab, and then pushing it over. Okay, so we'll go through that tomorrow in detail. Go ahead and do ODP 403. Let me know if you have questions. And we will talk about homework 2 tomorrow, because that's also a GitLab thing. So that's posted on Canvas. You can look at it, but we'll go through the details tomorrow. All right, that's it for our class. Have a good one. I will talk to you tomorrow.